Good evening, dear students. Yes. So we have started uh, the topic D and F block elements, right? So we are going to continue with the same in today's class also. So we know that the total marks allotted for D and F block elements is 11. Okay, so out of that, you'll be getting 3 marks, 3 questions. Okay, directly 3 marks, 3 questions, and 1 mark, that is 2 MCQs. So 9 plus 2, okay, 11 marks. So the total marks allotted for this particular chapter is 11 marks. So in the previous class, we have seen the MCQs from this particular chapter and 1 mark questions also. So these are some of the important 1 mark questions. Okay, so the 3 marks question can be asked directly. Okay, for 3 marks, or else 2 plus 1 mark. It can be asked for 2 plus 1 mark. Okay. Okay. So now we are going to start with the, so this give reasons are very important. So they can be asked for 2 marks. So some of the give reasons we have seen already, that is transition metals generally formed colored compounds. Okay, what is the reason? Then transition elements show variable oxidation state. Okay, another question. Then transition element forms complex compounds. Okay, another question. Then transition metals and their compounds are used as catalysts. Okay, so these are some of the important give reason type of questions. Okay, so here we are going to discuss the 2 marks questions now. Okay, so these give reasons are very important. So these are some applicative type of questions. Okay, which can be asked. So now we are going to go for 2 marks question. Okay. So 2 marks question. So the first question is, mention any 2 consequences of lanthanoid contraction. Okay. So what is the consequences of the lanthanoid contraction? So the first consequences is the radii of third row transition series elements. Okay, that is the metals are almost similar to that of the second row transition series element. So when you compare the radius of the third row and the second row, almost the what you say, the radius is the same, or it is almost identical. It is almost what? It is almost identical. Okay. So for example, says zirconium and hafnium. Okay, example, zirconium or hafnium. So these are the elements of third row and the second row, where you can see that the radius are almost same. Okay, why? It is due to lanthanide contraction. So this is the first consequences. Second consequences is the separation of lanthanoids in pure state. It becomes difficult. So when you want to separate the lanthanoids, okay, so in the pure state, it becomes very difficult. So there is very like to separate these lanthanoids in pure state, it becomes very much difficult. Okay, so these 2 consequences should be written in the lanthanide contraction. Okay, so this should be mentioned. Fine. So next question, what is lanthanide contraction? Okay, next question is, what is lanthanide contraction? And mention the causes for lanthanide contraction. What is lanthanoid contraction? And mention the causes for lanthanoid contraction. Answer, the overall decrease in atomic radii. Okay, so the overall decrease which is seen in the atomic radii and ionic radii from lanthanum to lutetium. Okay, so the decrease when you observe from lanthanum to lutetium, which is across the lanthanoids, then it is called as what? Lanthanoid contraction. So these words should be mentioned. Okay, so this word should be mentioned, the gradual decrease or the overall decrease. So this word should come. Okay, so in atomic radii and ionic radii from lanthanum to lutetium. Okay, to lutetium, okay, is called as lanthanoid contraction. What is the cause? What is the main cause for lanthanoid contraction? It should be they have very similar physical and chemical properties. Okay, they have what? They have similar physical and chemical properties. Okay, so this is the cause for lanthanide contraction. So please mention it properly. Fine. Next is what are interstitial compounds? So this we have discussed in the MCQs as well as in 1 mark question. What are interstitial compounds? Okay. So when a lattice is there, okay, when a metal lattice is there, so inside the crystal of the lattice structure, okay, of the metals, so there will be small space, okay, small space will be there. So these small space will be occupied by the small atoms, okay, with the these are occupied by the small that is these are occupied by the small atoms like your carbon, nitrogen, oxygen. Okay, so these atoms they occupy these okay, they are trapped, or you can say they occupy these spaces, and thus they form the type of compound which are called as interstitial compounds. What they are called as interstitial compound. Okay, so interstitial compounds are those compound when small atoms like hydrogen, carbon or nitrogen are trapped. Okay, they are trapped inside a lattice crystal of a metal. So for example, so please remember some of the example. First is titanium, okay, carbide, that is TiC. Then Mn4n, just a second, Mn4n, then Fe3H, okay, Fe3H, then VH 0.56. Okay, so the hydrogen stoichiometric ratio is 0.56. Then titanium hydride is that hydride proportion is 1.5. Okay, it is 1.5. 1.7. Okay, so this is the, so you have to remember any two examples. Okay, please remember any two examples, very important. Okay, so what are interstitial compounds is also one of the important question. Okay, and what are its characteristics? So characteristics also is very important. You have to study the characteristics also of lanthanide for of interstitial compound. So the next question is what are the characteristics? Okay, what are the characteristics of interstitial compounds? Okay, so what are the characteristics of interstitial compounds? Firstly, they have very high melting point, okay, than those of pure metals. So as compared to pure metals, these interstitial compounds, they have a high melting point. Okay, when you compare the pure metals, as you know, pure metals will have high melting point. So when you compare these pure metals and these interstitial compounds, okay, interstitial compounds will have high melting point. Okay, then second is they are very hard. Okay, as compared to the metals, the interstitial compounds are also very hard. Third, they retain the metallic conductivity. They retain the metallic conductivity. Means what? Because they can show the metallic behavior. Okay, so they will you, as you know, metals they conduct. Okay, so because of that they show the properties of metal, and these are chemically inert. Okay, these are chemically inert. So these are some of the characteristics of interstitial compounds. So please remember the characteristics of interstitial compounds. Okay, so very important this question. So what are interstitial compounds? What are the characteristics of interstitial compound, and give example. So please note down these important questions. Okay. So these are the like some of the questions you can see. Okay, when you go through the question paper, so there are some few questions which are asked repetitive. Okay, so that does not mean that these questions can be asked. Okay, but it won't be asked in the straight form. Okay, they cannot won't they won't ask you these questions are very important, but they will not ask you in the straightforward manner. Okay, they will ask you in a twisted manner. Okay, the questions can be asked in a applicative way. What are interstitial compounds? Give an example. Okay, so they won't ask you in this manner. Okay, they will ask you in a some applicative type of manner. Okay, so please remember these important things. Okay. Next, between titanium plus 4, okay, when you are seeing between the titanium plus 4 and titanium plus 3, Okay, which is more stable and why? So when we compare titanium plus 3 and plus 4, which is more stable and why? Yes, can you tell me the reason? Yes, titanium plus 4 and titanium plus 3. Okay, titanium plus 4 and titanium plus 3. Okay, so which is more stable and why? So titanium. Yes, which is more stable and why? What is the reason? So, so what is the titanium? Okay, just here, titanium. Okay, it is 22. Okay, so it is 1s2, 2s2, 2p6, 3s2. Okay, 3p6, 6, 12, 30, 40, 50, 60, 17, 18. Okay, 3p6, then 4s2, 6, 7, 8, 9, 10, 10, 16, 17, 18, 19, 20, and 3d2. Okay, now when it is titanium plus 4, so what will happen? The outermost is this, so it becomes only 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, 18 is argon 18. Okay, it becomes argon 18. And when it is titanium plus 3, what it becomes? Argon 18 plus 1. Okay, so it will be 4s1. So, which is more stable? So here, okay, here only one electron is there, but this is a complete stable. When you have noble, when it is completing its octet, okay, or it is nearer to the noble gas. So titanium plus 4. So titanium plus 4 is having a noble gas configuration. What we say that titanium plus 4 is having a noble gas configuration. So because of that reason, titanium plus 4 is more stable as compared to titanium plus 3. Because in titanium plus 3, again, there is a presence of one electron. Okay, so this again one electron. Because of one electron, it will be unstable. Okay. Next question. Transition elements, they show catalytic property. Transition elements show catalytic property. Give two reasons. The first reason is transition elements, why they show catalytic property. Yes, why does transition element show catalytic property? Catalytic property means what? It helps in changing the rate of reaction. Okay, it helps in changing the rate of reaction. Okay, it slows down. Okay, by taking a different path. Okay, and it requires very less energy to activate. So this is the role of your or this is a catalytic property. Now transition elements, they behave or they show this catalytic property. What is the two reason? First reason is that due to variable oxidation state. Okay, the first reason is it is due to variable oxidation state. Means what? The transition elements or the d block elements, they have the capability of showing a different oxidation state. Okay, they will show various oxidation state or they will show multiple oxidation state. So this is the first property. So because of that, it will have the catalytic property. Second is it is having a large surface area for adsorption of reactant. Okay, for adsorption of reactant, it will have large surface area. Then third is formation of intermediate compound. Third is what? Formation of intermediate compounds. So the formation of intermediate compounds, okay. So because of these also, okay, so they show catalytic properties. So these are some of the important reasons, okay, why transition elements they behave or they show this catalytic property. Next question, important question. So these give reasons are very important, okay. Next is transition metals generally form colored compounds. So why does transition metals they form colored compounds? That is, it is due to presence of unpaired electrons. So you know that whenever you have paired electrons, okay, they will be colorless, or when you have zero electrons, okay, or paired electron, they will be colorless. And when you have unpaired electron, okay, when you have unpaired electron, the compounds are colored. Compounds are colored, okay. So it undergoes what type of series? It undergoes DD transition. It undergoes what? It undergoes DD transition. So due to DD transition, okay, most of the transition compounds are colored. Okay, most of the transition compounds are colored. Next is with reference to the first row transition series. Okay, with the reference of the first row transition series. So which element has more number of unpaired electrons in ground state? So when you compare the first row transition series, okay, which element will have the more unpaired electrons in its ground state? Yes. With reference to the first ground state, first row transition series, okay, with reference to the first row transition series, which element has more number of unpaired electrons in ground state? Yes, students. Can you tell me the first row transition series? Yes, can you tell me which is the elements in the first row of the transition series? Scandium, titanium, vanadium, chromium, manganese, right? So here, okay, when you compare, okay, when you compare the electrons, so here it will be 4s2, 3d1. Okay, here it is 4s2, 3d2. Then vanadium is 4s2, 3d3. Chromium is 4s2, 3d5. Okay, 4s1, sorry, 4s1, 3d5. And manganese is 4s2 and 3d5. Okay, so when you compare this, okay, chromium, you can see that in the 1, 2, 3, 4, and 5. So it is 4s1 and 3d5. So you can see the number of unpaired electrons are how many here? Okay, so there are maximum number of unpaired electron in the ground state in chromium. So it is chromium. Second bit, which will exhibit maximum oxidation state? Which will which is the element which exhibit maximum oxidation state? Yes, it is manganese. Okay, manganese will show maximum oxidation state. Manganese will show the uh, oxidation state. Okay, variable oxidation state. So Mn, if you have seen the different compounds of Mn, okay, manganese. One is MnO2, another is MnF3, okay. Then MnO, then is KMnO, KMnO4, okay. Next is K2MnO4. Next is KM. sorry, K3MnO4, then KMnO4 also is there. Then this, I will write it up only. Just a second. So when I write the different oxidation state, MnO. So MnO, your the oxidation state is +2. MnO2, MnO2, the oxidation state is +4. MnF3 +3. K3MnO4 +5, +6, and +7. So you can see the maximum oxidation state, okay, shown by Mn is from +2 to +7. Okay, so these are the various or variable oxidation state or number shown by the different elements. Fine. Okay. So these were some of the 2 marks question. Okay. So now we'll see the 3 marks question. So very important. 2 preparations are very important from this chapter. The first is describe the process of preparation of potassium dichromate from chromite ore. Okay. So there are 3 steps. So there are 3 steps which are involved. So firstly is what? So this is a very important question asked for. Okay. Asked only. So what are the 3 steps? So first step is what? Step 1. Okay. So step 1 is chromite ore is heated. Okay. Chromite ore is heated. So with sodium carbonate and oxygen. Okay. And you get a sodium chromate. So chromate is FeCr2O4. Okay. 4FeCr2O4 plus when you heat it with sodium carbonate Na2CO3. Okay. In the presence of oxygen, what you get? You get sodium chromate, that is Na2Cr O4 plus 2Fe2O3 plus 8 carbon dioxide. Okay. Now, this was the first step. So, first step for 3 steps, 3 marks. Second step, what you have to do? This sodium chromate. Okay. Sodium chromate is treated with what? Sodium chromate is treated with sulfuric acid and you get sodium dichromate. So 2Na2Cr O4 plus 2H plus, okay, you get Na2Cr2O7 plus 2Na plus H2O, okay, plus H2O. So this is the second step. So what we are doing, we are converting the sodium chromate into sodium dichromate by reacting it with sulfuric acid. We are treating it with sulfuric acid, concentrated sulfuric acid. Next step, what we are doing, the sodium dichromate which is formed, that is Na2Cr2O7. Okay, we are treating it with HCl. Okay, that is potassium chloride. We are treating it with potassium chloride, and we get a potassium dichromate. What we get? We get potassium dichromate. Understood? We get a potassium dichromate. So for 3 steps with proper psychometric ratio and all, 3 marks. So 1 mark for each step. Understood? Okay. So please note down the questions. Very important. Okay. So these are the very important questions. So preparations is asked. Okay, a must question to be asked from this particular chapter, that is for preparations. Okay, preparation is asked only from this chapter. Okay, understood? Is it clear? Shall we move for the next? Is it clear? Please note it down. Please note it down. Okay, fine. So how is this process? Okay, we are taking once more, we'll revise. So chromite ore, okay, we are treating chromite ore with sodium. Okay, we are treating it with sodium carbonate and we are passing it with oxygen. Okay, what we get? We get sodium chromate. What we get? We get sodium chromate. Okay, this sodium chromate is further treated with sulfuric acid. Okay, we are treating it with sulfuric acid and we are converting into sodium dichromate. We are converting into sodium dichromate. This sodium dichromate, okay, sodium dichromate, we are treating it with what? We are treating it with potassium dichloride, potassium chloride. Okay, potassium chloride. What we get? We get potassium chromate. What we get is potassium dichromate. Okay, so this is the answer. So like this, stepwise, if you write properly with proper psychometric ratio, okay, and these are also very important. So these are also very important. Okay, NaCl, Na plus. So these are also. Okay, so this was the answer to be written for chromatode. Okay, next, second question. Describe the preparation for of potassium permanganate from MnO2. Okay, how do we prepare? How are we going to prepare potassium permanganate? It is KMnO4 from MnO2. Okay, now the first step. So here also it involves three steps. Step one, step 2, and step 3. So what is the step 1? Step 1, we are fusing MnO2, okay, with KOH, potassium hydroxide and potassium nitrate. Okay, and what we get? So we are treating the potassium MnO2, we are fusing MnO2 with potassium hydroxide and oxygen. Okay, and what we get? We get K2 MnO4 2 K2 MnO4 plus 2 H2O. Okay, this is green in color. This is what color? This is green in color. Now this potassium manganate. Okay, this is what? This is a potassium manganate. This is potassium manganate. So this potassium manganate, that is K2MnO4. Further, okay, K2MnO4, we are treating it with sulfuric acid. We are treating it with acidic solution, and what we get? We get potassium permanganate. What we get? MnO4 minus plus MnO2 plus 2H2O. Or the second step, okay, or the second step can be also written by taking the electrolytic oxidation. So if we pass when we do a electrolytic oxidation of manganate, okay, if we do a electrolytic oxidation of manganate, it gives you permanganate. What it gives you? It gives you a permanganate. So how will you get it? MnO4 2 minus, if you do a electrolytic oxidation in alkaline solution. Okay, we are going to do electrolytic oxidation in alkaline solution. You get MnO4 minus. Okay, so these are the steps. These are the steps. Okay, understood? Is it clear? Yes, student, is it clear? So these are the steps for the preparation of potassium permanganate. Okay, from MnO2. So first step is what? We are fusing MnO2 with KOH. Okay, and we are providing an oxidation medium, and we are converting into potassium manganate, which is green in color. Now this potassium manganate, it is in a neutral or acidic medium. Okay, it gives you a permanganate. Okay, so we are getting a permanganate. Or the second step can also be done as we can do electrolytic oxidation. We can do it electrolytic oxidation can be okay. We can do electrolytic oxidation on the manganate, and it can be converted into permanganate. So you can see MnO4 2 minus in alkaline solution, electrolytic oxidation in alkaline solution, you get MnO4 minus. Is it clear? Are these questions clear? Yes, students, any doubts still here? Any doubts? So we have seen 2 marks and 3 marks question. Any doubts still here? The preparations are very important. Okay, preparations are very important. If you have any doubts, please ask me in the chat box. Okay, you can ask me in the chat box. If you have any doubts, you can drop your queries there. Okay. I'll ask you some questions. Okay. First question. So between titanium plus 3 and titanium plus 4. Okay. Titanium plus 3 and plus 4. Which is, which ion is colored? Which ion is colored and why? What is the reason? Which ion is colored and why? Yes. Between titanium plus 3 and plus 4, which ion is colored and why? Yes, students. What is the reason? Yes. Titanium plus 3, it will be argon 18, 4s1. And titanium plus 4 will be only argon 18. Okay. Now, can you tell me? Yes, can you tell me? Try. Which is colored? Which is colored? And why? Between titanium plus 3 and plus 4, which is colored and why? Yes. No answer. Did not understand. Yes. Which is colored? Whenever you have unpaired electrons, it will be colored, right? Unpaired electrons are in titanium plus 3, right? So titanium plus 3 is colored, okay, because it contains one unpaired electron. So this is the reason why it is colored. Okay. Next question. Atomic size of 4D and 5D series. Atomic size of 4D and 5D series elements are almost same. Okay, that is of hafnium and zirconium. The size are almost same or they are identical. What is the reason why the size is identical or they are similar or they have almost same size? What is the reason? Yes, you can use a chat box to answer me. It is due to lanthanide contraction. Okay, it is due to what? It is due to lanthanide contraction. So why 5D and 4D series, they have almost same or identical size? It is due to lanthanide contraction. Okay, it is due to lanthanide contraction. Okay. Can you give some differences between lanthanoids and actinoids? Can you state some differences between lanthanoid and actinoids? Can you state some differences between lanthanoids and actinoids? Yes, lanthanoids. Here, 4f orbitals are progressively filled. 4f orbitals are progressively filled. Okay, here 5f orbitals are progressively filled. Okay, here 5f orbitals are progressively filled. So these are the first point. This is the first point. Now, second point, these are less reactive. Lanthanoids are less reactive. Actinoids are more reactive. Actinoids are more reactive. Then lanthanoids, they show maximum oxidation state of +4. They show maximum oxidation state of +4. In actinoids, the maximum oxidation state shown is +7. The maximum oxidation state is shown is +7. Here only promethium is radioactive. The only radioactive element is promethium. Okay, it is promethium. And here all are radioactive. All are radioactive elements. So these are the differences. Okay, these are the differences between lanthanoids and actinoids. Okay, these are the differences between lanthanoids and actinoids. Is it clear? Yes. What is the composition of mish metal? Composition of mish metal. Okay, so mish metal is a alloy which contains 95% lanthanoids. It contains 95% lanthanoids and metal, lanthanide metal, and 5% iron, 5% iron plus traces of sulfur, carbon, calcium, and aluminium. Okay, and where it is used to produce lighter flint. Okay, it is used to produce lighter flint. So, yes, correct. Yes, so these are the composition of mish metal. Okay, so the composition of mesh metal is 95% lanthanide metal, 5% iron, and traces of sulfur, carbon, calcium, and aluminium. Okay, so these are some of the important questions from this particular chapter. Okay, so any doubts? Do you have any doubts? You can ask me now. So we have completed the chapter. Okay, D and F block elements. So we have left with two more chapters. So next we are going to start with chemical kinetics, and then at last we are going to see the coordination compounds. Okay. Any doubts in today's chapter, students? If you have any doubts regarding today's session, you can ask me now. You can drop your queries in the chat box. Yes. Others? Any doubts? I hope Suchit has understood everything. He said no, ma'am. Okay. What about others? How are your preparations going on? I hope everyone is actively studying. Yes, good. Okay, fine. So whatever the things are told, whatever the important things are told, please stress more on that. Okay. So it will help you to score well. Okay. It will help you to score well. It will, okay. So whatever the things are told, whatever the points are told, okay. So if you concentrate on those points, so it will help to increase your percentage. Okay. So these small things only will help a lot in at last moment. Okay. So no doubts, right? Okay. So we have completed the chapter D and F block elements. So this particular chapter, okay, it will fetch you 11 marks. So do a proper, okay, so I've told you which are the important questions, which are the important things. So please stress on those questions, those points, okay, how to write. So for each point, you'll be getting 1 mark. So study it properly. So all the reasons, give reasons, okay. So preparations, very important. What is lengthened contractions? What are interstitial compound characteristics of interstitial compound examples? Okay, the give reasons all questions, okay, about transition elements. So these all things are very important from this particular chapter. So please study well, okay. Fine then. So I shall end the session here. Okay, so we'll meet in the next class. Thank you.